We can. I can see it. Thanks, Garth. I'll pass everything on to you.
Awesome, thanks. And thanks for letting me present. This is a presentation based on some experiences I had with a client engagement in working with Terraform and their DevOps pipeline. So this is really a blow-by-blow account of our experiences and my experiences in trying to work through a number of different challenges. So I hope it'll be useful for someone else in the sort of state, it's too late for me, save yourself. Just a note that if you're, because I will share the deck, there are some animations in this. So there's one particular slide that will look like an explosion at a spaghetti factory. So turn on the animations, particularly for that slide, and it should make more sense. The other thing that we should be aware of is that because there are screen captures from Azure's portal, and it is a platform and their GUI, it is continually changing like every service. And so what you may see may be different than what was captured at the time this slide deck was created. So gratuitous slide about me. I like beer. Any questions? My background was, my academic background was engineering, and with my professional career, each project got closer and closer and closer to security, starting with military message handling, key management, public key infrastructures, cryptography. And that gave me the opportunity also to work in the red team world for pen testing and threat modeling. So when I'm asked, are you a builder or a breaker? My answer is typically yes. And as with working with various employers, as everyone is stumbling towards the cloud, I then start to work more in the cloud application, web application cloud security space. So this becomes now more lately the DevSec whatever you need. And so that's based on some of this slide deck is based on some of the work I did there. So as was mentioned, I started volunteering in OWASP Ottawa's chapter, and now I'm a co-lead with Sharif Kosa, who was the founder of the chapter. At the moment, I'm an independent contractor under the name Devious Plan, but enough about me. Quick agenda. We're going to start with a problem statement. We're going to talk a little bit about background, technical background for those that need it in terms of infrastructure as code and specifically Terraform. We'll try to define the problem space a little bit more, and then we'll look at the corporate standard requirements and how it affected our lifestyle. This, of course, introduced some challenges, and so we'll spin the twister dial and look at the proposed solution as well as a comparative analysis of a risk assessment review between that MVP happy path that is often presented to us and what we really needed to do on the ground. And if we have time, we'll walk through some configuration screens as well as some code. For Q&A, we can have Q&A at the end, but if anything pops up at the chat, if somebody is watching the chat and wants to interrupt me, that's okay too, because when I present, I prefer it to be more of a discussion than just a presentation. Anyways, let's look at the problem statement. Create an automated infrastructure as code pipeline following corporate standards. Nice, vague, aspirational requirement, which is sort of like the same sort of thing you read on what your vet tells you to do when you're trying to give medication to your Great Dane or some other animal. It sounds simple on the label, but when you really try to do it, it becomes a little bit more complex. So to set the background for this, we need to talk a little bit about infrastructure as code. And we could call it a movement, but there was movement towards using infrastructure as code because managing data centers virtually was becoming a bit of an issue. And so infrastructure as code wants to be able to use some form of machine readable file as per the definition, instead of something that's manual and interactive. And the reason for that was that managing large deployments in the cloud had a number of issues in the manual interactive configuration mode, and that was scaling. How do you scale a large deployment when you're having to do it manually? It just does not scale. And because it's manual and interactive, you've got this thing called a human involved. And as we all know, humans make mistakes. So infrastructure as code was born to address these because we wanted something consistent, something predictable, something that we could work with, that we could test, we could bring in a whole number of tools. And like with any good idea, there was a stampede in terms of people wanting to do this kind of thing. So we have CloudFormation in AWS, we have ARM templates in Azure, and then we have this thing called Terraform, which is a focus of this discussion because this was also a client requirement. So if we want to talk about Terraform, and as I was learning about that environment, it's supposed to be supported across a large number of different types of environments. And I have a question mark there because when I first heard about Terraform a few years ago, it got presented to me in a vague way as if I could run Terraform on any environment. And that was true, but the implication was I had one piece of code. But what I sort of have learned in this exploration is that, well, yes, I need plugins for specific environments. I need specific tools to be able to deploy and have that file created to build that environment specific to that environment. So it is supported across a large variety of environments, but your mileage may vary based on the environment you're in. So I left the question mark there. It uses a declarative model. So I can tell it what to do, not how to do it. I can tell it to go make a coffee, but I'm not going to tell it how to make that coffee. I don't have to install agents everywhere. So my deployment doesn't need to have agents littered all over the place. And it doesn't need a mothership to control everything as a single point of failure. Now, by now, it's starting to sound to me like the modern equivalent of the smokeless ashtray, but we'll keep going. It's got a large community of support. So, you know, there's somebody's shoulder to cry on. And it's got this thing called idempotency, which is specifically related to its state. And so, you know, if we think about this for a moment, you're wondering, well, what is idempotent? And rather than it being some sort of wasting male performance disease, it's actually something related to the property of its operation. So idempotency can be explained as like the delete command. And if you forget about the notion of a trash can on your desktop, once you delete something, it's deleted. You cannot re-delete it. So that is an idempotent operation. Idempotency means I can apply that operation multiple times, but nothing will change beyond the result of the first time I called it. So if I have a Terraform file that says create a virtual network and I run it and it builds that virtual network, and then I run it immediately again, it's not going to build a new virtual network. It will recognize that that virtual network already exists and says, I've got nothing to do here. But how does Terraform do that? And it does that in the way it needs to remember the state. And that state is what supports the operation attribute of idempotency. So, okay, so we shift our focus now. All right, it's got all of these great things. I don't have to install an agent. I don't have to have a mothership controlling and watching everything. But it has this thing called state. And how does it support that state? And so with Terraform state, it has a state file. So it maintains its notion of what is running, what's in the environment, what's on the ground in this thing called a state file. So what goes into it? And there's quite a bit. And of course, based on your environment, your mileage may vary. So, I won't rattle off the whole list here, but there are some things there that might catch your eye. They might be juicy to an attacker if they got a hold of it. So, there may be some things in your state file that you may want to protect. And so what Terraform does is it's using the state file on every operation to maintain that consistency and synchronize the reality with that state file. And I'm just going to pause for a moment to see if there's any questions and have a drink.
Nothing pasted in chat right now, Garth, but if anybody has any questions, feel free to put it in chat, or I could say interrupt Garth, but whatever. Good stuff. Okay, so we've got a state file, and we need to now say, well, what is our risk analysis of the situation? It's got some information in it. What is my usage of this state file? And therefore, based on my usage and its exposure, what are my requirements to protect it? And I know if there is one person alone building one deployment, and they've got a laptop that's secure, they're doing backups, it's just them, then probably a lot of infrastructure to support that state file and the protection of that state file may be unnecessary. So you have to look at how you're using it, how you're sharing it, to be able to say, what do I need to do? But in our case, because this is being used in a pipeline, there are teams scattered across different time zones and different places, we may really want to pay attention to this in terms of the security and its continuity. So in our case, a team that's scattered across the world in different time zones that may need to be able to modify or look at this state file, or we're using a pipeline that could run whenever, wherever, we need to now pay attention to this. And we sort of sit back and contemplate it. Well, what if now there's nothing, we look at the state file and there's nothing we would consider now that is risky for its exposure? And that might be a fair assessment. But the problem is feature creep, and that you don't know what's going to happen and how your deployment will change in the future. So my decision at this point in time is, well, this could go any different way. So we will secure it now, and then we don't have to worry what gets planted in it later. So then we go through, we dust off, we pull out our CISSP, textbook that's, holding up the microwave, and we look through and look at the CIA triad. What do we need to worry about here? Well, we need to worry about state file security at rest, in transit, and who's got access to it. What can they do with that file? And then I'll add a fourth one. How are we backing it up? How are we tracking its changes? How are we making sure that when the data center that's housing this state file becomes a smoking crater, how are we able to recover from that? And so because this particular client seems to have both feet in Azure, we're going to look at using an Azure storage account. So when we were looking at this, we sort of wondered, well, what is this going to give us? We wanted to be as simple as possible. What do we get out of the box? And so at this point, we're looking at, what's happening at rest. Well, in a storage account, we get out of the box encryption. We can layer other encryption on top of it optionally, but we get something out of the box. If our risk profile requires encryption upon encryption with our own managed keys, well, that's possible, but at least we know out of the box, there is confidentiality at rest. What about data in motion? Well, this file is going to be moving around. It's going to be accessed from different things potentially. So we want to make sure that there's TLS involved. So we get that. Who's accessing it? Well, we can attach this storage account to Azure Active Directory, so we can control who can do what when. And for continuity, we can enable versioning and snapshots to, and the usual cloud redundancies to be able to make sure that we always have this file and we can, revert to different versions. We have that ability to restore ourselves if something goes south. This all sounds great. So obviously there's a client involved who's paying for our time. So what do they need? So they want to use an Azure storage account. Good, we're with them, and they want to use TLS. So they're preaching to the choir at this point. So that's good. They know enough that they want this file to be encrypted at rest. So we're walking the path with them. That's great. And they want it to be kept dark. Only those with a business need to be able to access it can access it. So we agree with them on that. Thou shalt use Azure DevOps. Okay, whatever, we can work with that. That's fine. No public internet file access. And yeah, I understand this requirement. I would agree with this requirement. And with apologies to Las Vegas, they want to compartmentalize whatever happens to this file has to stay within the subscription. So this is good, but that last or second last bullet point was probably the main point of grief. And not because it's not a good idea, it's an absolutely excellent idea. It's just the attempt to implement it and work around the configuration is probably what will occupy the rest of this slide deck. All right, let's talk about challenges. The chicken and the egg. This is something anybody new to Terraform and involved with state files will encounter. And it's a simple case of you cannot use Terraform to create the infrastructure to support your subsequent Terraform with Terraform. If you think about it, well, if you're running Terraform, you need a state file. But if you're running Terraform to build something to protect a state file, then you need a state file for that. And then it becomes turtles all the way down. So once you realize that you're in this sort of inception arrangement, then you realize, yeah, I can't do that. I have to do something a priori in advance, and I have to do it manually. So that one particular thing has to be done either through the portal or the command line interface to be able to build that infrastructure that will house that state file. You can use, in this case, because we're focusing on Azure, you can use the portal. You can use the AZ command for the Azure command line interface, or you can put it in a bash script. That works. Depending on the nature of your pipeline, it's probably, and I'm going to guess typically that you're going to do this once and that's it. You once documented, hopefully. And then that's once it's documented and in the infrastructure, you don't need to worry about it again. The bash script is useful if you're wanting to redeploy a lot. So whether you would need something like that is your mileage may vary. But if you're using a bash script or you're using the Azure command line instead of the portal, you have to be aware that when you're using the portal, there's a lot going on behind the scenes. And so in the creation of building a bash script to do all these things and, getting so far and having it fail and we're missing something, and then you realize, oh, the portal, when you went through the GUI, there were these other things that we created. And so then you build those in your bash script and lather, rinse, repeat, until eventually you get to a bash script that does all the commands that the portal did that wasn't initially obvious to you. So that was my Terraform chicken and egg. The next challenge, and I'm looking at you, Cosmos DB users, is the notion of a lot of things being public by default. Now, maybe I'm just paranoid and I just like things to be totally locked down. Nobody can see anything. And then you only open up what you need, that you have a business reason to need, as opposed to wide open everything and then you lock it down. But maybe that's just me. But one thing in my path in Azure is that there seems to be a lot of things that are public by default. So if you're this type of person that goes into the GUI and nexts through the configuration, you're going to find that things are going to be public by default. So it will have a public endpoint by default. And it's not just with storage accounts. I found it also in other things. Instead of your storage account accept connections from anything on any network, if you create a virtual network, say, so you've got a private virtual network in Azure, and you create a private managed database, and you want to be able to connect the two, I think it's a reasonable person that would reasonably assume that if you've got a private network and your private in your subscription managed database, that they would talk only within Azure's backbone. Instead, what you find out is that you are actually talking over the public internet unless you actually set something perfect or set a private endpoint. So the other problem I had with, particularly with storage accounts, is that most of the documentation that is available, and I think by now my Google foo is pretty strong, most of the documentation seems to want to follow that public endpoint happy path, and that everything that talked about configuring your pipeline or your Terraform with the storage account was expecting to have a public endpoint on your storage account. And so that type of documentation wasn't really very, very helpful. Now, this is sort of where my rant is a bit on things that are public by default. When you're building any kind of infrastructure, you have to pay attention, because a lot of these Azure services are managed by or made public by default. And so I gave the example of the virtual network to an Azure managed SQL database. And so in these cases, you have to set up a private link and a private endpoint explicitly to ensure that that traffic is private between those two entities within your subscription. Now, my hope is that this, in the fullness of time, will change so that it will be private by default. But at the time of this writing, at the time of this work, it was public. All right, and then we get to Azure DevOps. So my first thought is, okay, right, it's Azure, right? So we're in the house, we've got Azure components talking to Azure components. So there should be some, I don't know, agreement that I should be able to connect this to a private and this my account in Azure DevOps to my private virtual network over a private connection. This should be, straightforward out of the box because it's Azure, right? Right? Unfortunately, no. Imagine my surprise when I learned that Azure DevOps is not actually Azure. It's a completely separate product. It's hosted in Azure, but somehow it has the Azure branding, but there's no special agreement. There's nothing that says that there is some special agreement that allows us to connect to these things. Pause for questions.
It is a Microsoft product, though, isn't it?
It is. It is. You are absolutely correct.
Maybe it was an acquisition or something that they tried to fold in.
Maybe. Maybe that's definitely more than possible.
Interesting.
Imagine my surprise. Imagine me virtually pulling my jaw off the table. All right. So, okay, it's not Azure. But I can do something else, right? I can use my Azure storage firewall, set up an NSG and say, it's a trusted service. It's, Microsoft, right? I can say that that's a trusted service that can access my service account or my storage account. And, it's got the name Azure. So there's got to be something. I got to be able to say, yeah, that's trusted and allow that traffic through. Nothing else can get through. That should work, right? Right? Nope. It's not a trusted service. And that's, the second time I'm pulling my jaw off the table is wondering, well, what's going on here? And I'm not the only one. This particular link points to an issue within Microsoft documentation on this very subject. And there's a lot of people going through the same stages trying to wonder, well, I'm trying to connect these two things. I've got two Microsoft products, both with the name Azure. What's going on here? But there's no joy. Okay, all right. Okay, let's move on. What else can we do? We can say, well, it's not an Azure product, but it's hosted in Azure, right? So I should be able to use their CIDR ranges to be able to set up something with my firewall to say just that traffic from that location, right? Right?
You're standing up here, man.
I like a little drama, right? No, well, you can try, but they changed their CIDR ranges every 2 weeks. Pause for effect. So what you'll find is as you're Google fooing, right? You'll find that the web is littered with people writing these scripts, spinning twister dials, trying to limbo their way through to pick up their published CIDR ranges every 2 weeks and then adjust their firewall rules to be able to accept that traffic. And I'm waiting for somebody to tell me that that is production grade. So that's not going to really work for us. And so we move on. What was the next challenge? Well, in one of the solutions we were looking at was the use of virtual machine scale sets. And we'll go on to more details about using them later. But the sort of little surprise I got here is that, say I've focused on one particular machine image, let's call it an Ubuntu 18 LTS, right? And I'll, create a virtual machine from that image, and it will have all the modern conveniences I need. It will have the Azure command line for Linux on it, and it will also have Terraform installed on it, and that's great. And so if I'm creating a virtual machine set or machine scale set from that image, I would expect that when that scale set spins up that image into a VM, that it would have the same modern conveniences of Terraform and the Azure command line. Is that an unreasonable thought? Right? No. Imagine my surprise when my pipeline face plants, when it can't find the Azure command line and the Terraform command installed on it. So I immediately go and start comparing the VM that I tested with this manually before that, and they are there. I create a new VM. Has anything changed? No, they're there. Why are they not in the virtual machine scale set? I don't know. I do not know to this day. I've been able to work around it, and we'll talk about that. But that was my fourth challenge. So by this time, I'm sort of wondering what stage I'm in. I'm not going to bore you with all the different stages that I went through with this, but eventually I got down to the acceptance and hope stage, where we have to accept that there will be some kind of public internet traffic between Azure DevOps and Azure. We just need to move it to a place that is within our risk tolerance. So we know we don't want that public traffic on our Azure storage account. Can we move that traffic to somewhere else that's within our risk tolerance? And that works within the corporate standards that have been set for us. And so where we go with this will be eventually to move that public access from the storage account to a virtual machine scale set. So let's get started. Let's get our virtual shopping cart and go shopping. So the first thing I like to do is group everything in a resource group, sort of like a bag of holding, if you know what I mean. So everything I create is contained within one area. And so I need a virtual network. I need a virtual machine scale set. I need a storage account, store the state file. And that storage account is going to need a container, which will have the state file blob, and it will need a private link. And then, and this is very, very key, I need a service principal. And that service principal, that identity, needs to have contributor access to both the scale set and the storage account. And we'll see how that service principal acts in terms of how it's linking these things together, particularly with Azure DevOps. So we're done with the Azure aisle. So clean up in aisle 4. We're in the Azure DevOps aisle where we need an account in Azure DevOps, but we need this thing called a service connection. And so if I pull out my Azure DevOps phrasebook, I know now that it's actually their construct for accessing or their counterpart for my service principal. So this is really my Azure identity in Azure DevOps. We'll create an agent pool, which if you're familiar with Azure DevOps, they create pools of systems. So if you have a release pipeline, all the commands that are being executed in that pipeline are done in a virtual machine managed by an agent pool. And they do that automatically. But if I want to control that and have it in my environment, I need to create my own agent pool. And that will point to my virtual machine scale set. And then we need the pipeline. And that's where the rubber meets the road, where we have our script plugins that run our Terraform commands within that agent pool, within that virtual machine scale set, within our Azure account. And we'll, if that sounds like it's starting to get a little complex in text form, I have a graphic. And this is where the animation is. I'll just pause for questions for a second. Sounds like I've killed them all. All right, so what's the first thing? Well, we need that service principal. So we need this identity, which we configure in Azure AD, and it is the central character in this play. It's going to be that thing that gives us access between our Azure deployment and our Azure DevOps pipeline. So its counterpart in Azure DevOps is the service connection. So we need some infrastructure. We need our virtual machine scale set that will be running our commands and our Terraform building. And our service principal needs to have contributor access to that. And by association, because our service connection in Azure DevOps is the counterpart for that service principal, it will by default have that access, that contributor access to the scale set. We'll need a storage account, surprise, surprise. We need all the modern conveniences of encryption by default at rest and TLS 1.2, so we'll configure that. And it also needs contributor access from the service principal, and by extension, the service connection has that contributor access. So they need to be able to talk to each other. So we're going to need to not have that public endpoint. So we'll create a private endpoint and we'll attach it to a virtual network. And then, of course, that virtual machine scale set needs to talk to that same virtual network through the private link to the storage account. So on the Azure DevOps side, we need to create an agent pool associated with that service connection. And that agent pool needs to identify that virtual machine scale set to be able to run that pipeline. So once that connection is established, then we can run our pipeline. The key thing here is that the connection points are that we're using that service connection and its role as that service principal with contributor access to be able to access that scale set to deploy and run those Terraform commands. Now you're looking at this and you're probably wondering, well, you can probably tell where the internet communication is. So let's just do a quick review between what we were faced with before and what we are faced with now. And before we had a storage account, that boxy thing at the bottom, with an endpoint that was accessible publicly from the internet, and that was suboptimal. Now what we've done is we've restricted all communication to that storage account only from our virtual network, and which is only talked to by our virtual machine scale set. However, our internet communication from Azure DevOps on the left, the pipeline rocket, is now talking through the internet, through the Azure API, to the virtual machine scale set. So we still have the risk of using an internet endpoint, but it's managed through the Azure API, relying upon that managed identity, which is contained within that service connection in Azure DevOps. So there are still risks here, but they're risks in which this particular client can manage because they will accept that risk of using the Azure API. I'll just pause for a moment. So the risk is not completely removed, but it's in a place where in this particular scenario, it's in an acceptable location. Notice we're not using Cosmos DB. Anyways, so we're relying on Azure to do the right thing in terms of managing their API and managing their API access. So how are we doing for time?
Still got about 20 minutes left.
Okay. So just a quick review: private IP, storage account, private IP, connected only to the virtual network, private access only through the virtual network, and a virtual machine scale set only connected to that virtual network. Of course, the internet communication between the pipeline and all our infrastructure is through the managed API over TLS. And I think that's about it for that. So the next thing is some screenshots of some configuration. And so the first thing is the enable secure transfer, which is GUI speak for turning on TLS. So TLS good. Why is this even an option? You can enable infrastructure encryption. Now, remember, it's encrypted by default with their system key, which you don't manage, and that may be acceptable for your risk profile. But if you want to up the game a little, you can enable infrastructure encryption and do your own key management and apply your own key and raise at that level. But that's your call based on your risk profile. Enable blob public access. And notice this is not the only place where you can enable public access. So be advised, there are other places, but do not check this if you do not want public anonymous access. You can also control access through a storage key or a token. You wouldn't necessarily need this, and in this screen capture, I was trying it out, so you may not need this at all. And if you want to decrease your TLS version to a more vulnerable version, you can do it here. And why is that even there? I'm not sure, but there you are. Onto the networking part now, you can also enable public access. So here you go through the process of setting a private endpoint. And this is not the default setting, so careful when you're nexting through. And then you go through the process of creating that private endpoint, giving it a name, and identifying the virtual network that you're actually connecting it to. Be advised that if you create a storage account with a private endpoint and connect it to a virtual network, you will not be able to send traffic to it because that virtual network will not be able to route to it. And so here you need to enable private DNS integration. Otherwise, it won't be able to find itself, or find your storage account. So this needs to be enabled. And then we get into the Azure DevOps and starting with an agent pool. I find the Azure DevOps interface a little bit of a French forest. The UI, at least to me, hides things. They're sometimes a little more awkward to find. So where you find some of these things and where they are located is sometimes not always clear to me. Maybe it's because I started my career doing GUI development for Windows 1.0, but I can work through that. So gear icon at the bottom, or what you'll see called project settings. And then from there, there'll be agent pools, and then you create an agent pool, but you will need a service connection, which I won't show here, or a virtual machine scale set in Azure. And here it's just a linkage. Here you're saying, yeah, I'm going to create a pool. There's my virtual machine scale set. And here is my service connection, which is my identity in Azure DevOps. And you can fiddle with, at the bottom, the number of machines in that scale set, or the number of virtual machines that you will be using in your build, and how you want to deploy depending on your performance requirements. And that's reasonably straightforward. But then in the pipeline where you're actually doing your stuff, your Terraform, you need to then be able to talk to and identify that agent pool, because you don't want to use your default agent pools. So this is a little more complex in that you're doing this in a release pipeline as opposed to a build pipeline. And so you're selecting pipelines, and then from there releases, and then over on the right, you will find new, and then you can do new release pipeline. And this took me a little bit of time to figure out where, on the left side or on the right side, or, is it this thing that, oh yes, down here under new, there's new release pipeline. So eventually you find it. And then you're in the process of creating an empty job and then adding an artifact. And adding an artifact, let's get your Azure DevOps phrasebook. Your add an artifact really means point to that code in your repo, and that's where your Terraform code is. So once you've pointed to that, and you have essentially identifying the branch and code location on the left-hand side, then you want to add something called tasks to be able to run content, to be able to run specific Terraform tasks. And as you're casting about, wondering, well, how do I turn that on? You'll notice that the tooltip that says view stage tasks, well, that's actually where you're creating it. And once you find that and click on that, you're presented with a tasks window. And from there, you can actually start adding stuff to run in the agent pool that's running on your virtual machine scale set. So you're going to start with adding an agent job, which identifies the agent pool that will link this job to that pool. So we're saying, here's a job, go run it on this virtual machine scale set or agent pool. And now we start to add, finally, tasks. And the very first one I have to add is bash. And why do I need to have a bash task? Because I need to install Azure command line and the Terraform command on the VM that's spun up. You remember from a previous slide, this wasn't on the VM that was spawned in the scale set. Well, this was one way around it. I was actually on every release pipeline build doing the install. In retrospect, the better way to do it would be to build my own VM and capture that VM image, and then use that VM image when I actually spin up the scale set. So I wouldn't have to do this install every time. But once you have it installed, now you have a bash script that's running, then you can start to add other things like Terraform or maybe any other infrastructure as code scanning tools to scan your Terraform or your repo. And so in the case of doing a Terraform init, you're actually pointing to your subscription where your state file will live. So you're providing the resource group, storage account, container. But I think I've got more animation here. So the first thing we need is, where's our code? Where's the repo for our Terraform? Where is the service connection? What is our identity in Azure? Then it's a case of all the other things, the storage account, container, and the key. Get your phrase book. Key in Azure DevOps means the name of the state file. So you have all those things to point to that state file. And then the plan is a little more straightforward. You're just providing additional, your service connection, which is your what they call your Azure subscription now, and any other variables in terms of output for your plan file. And then it's apply. That's pretty much straightforward as well. And that's the bulk of the presentation. If you're really up for punishment, I have the slide deck has screen caps of the bash script that sets up the infrastructure, but I'm thinking you've probably had enough by now.
And obviously Garth has a Q&A here if anybody has any questions related to Azure and setting up Terraform, or just Terraform in general too, I assume. You went really deep into this, Chris. I'm sorry.
Sorry, was that a little too intense?
Somebody's asking, well, we need a certificate for this subject. So is Bill asking for the meeting, or just for learning all the stuff Garth has had to go through to get this far?
Check my account on Amazon. I'll send you brains in jars.
Just pop those in and get all this stuff going. That was deep. That was tough.
The biggest thing that shocked me was that everything, like the first thing, you're going through this and you find all these things, and then you start casting about, who's blogged, who's tweeted, who said something. There has to be another human who has talked about this. And imagine my surprise when everybody went for that MVP, or minimum viable product, happy path of putting their state file on a storage account through a private endpoint. The interesting thing also was that this, not using a public endpoint was an internal corporate standard with this client, and they hadn't deployed anything associated with it. So it was a theoretical, let's throw this up against the wall and see if anybody can make it stick. And I was the victim in that case, in that I was that first one in this organization who actually had to do it for a project. And so then when you go on the internet and you've got years of Google foo experience and you're finding nothing, you're finding everybody using the happy path, then you actually become a little scared because you don't want to do a deployment that has to talk over a public endpoint and mess it up, because this was happening at the same time that we're reading about solar winds. And this is a pipeline. And so
public versus private, definitely. I mean, you're trailblazing here on getting this stuff set up. Nothing like being that because the policy guys told you had to be this way. It's lots of fun, huh? Well, it's very cool that you got it working though.
So it's sorry.
I was going to ask if you've reached out to the product team of the Azure product team, or the teams responsible for these products, to share your learnings. I'm just kind of curious.
I have not done that as of yet. As it turns out, this particular client has a specific account rep, but they're sort of incommunicado because the rep has now moved on to other things, and there's a new rep who's on holidays. So I'm not quite there yet, but that's actually a very good point, and I'll make it a subject of something to do in the coming weeks. The challenge here also is that anything in the cloud is a moving target. And so as things are constantly evolving, I'm sort of wondering, well, how will this need to evolve? Will there be more secure defaults? Will Azure DevOps be with the purchasing of GitHub? How will that change things? So it's, and in addition, how will the internal corporate standards evolve? So we have a number of moving targets, but the main thing here is for this particular pipeline is I don't want things to get exposed because there is a certain amount of sensitivity with any platform, with any deployment, but there are some very specific needs that I don't want to be exposed on my watch.
And someone mentioned in the chat, is this type of activity going to be written to the DoD standards?
We did the what?
The DoD standards, and so Microsoft is the vendor for the DoD cloud. So it's like, what you did is perfect for what they will probably need too.
I think this is starting to sound more like publish or perish. I don't know.
I don't know. Yeah, that's what you did. Is publishing this would be a great, just the learning path for people to be able to do this. And so somebody like you, somebody had to trailblaze it.
Well, I mean, maybe what I could do is put up a GoFundMe for my, therapist.
You like my solutions, do a Patreon or something like that. Yes.
So yeah, I direct fund my therapist. But anyways, it was a challenge, and to get that state file actually popping up in the storage account through all these dominoes was that was a moment. So that was a moment of success. And in fact, the group that originally authored the internal standards are sort of actually surprised, and now they want me to actually go through this with them.
The client internal standards or the Azure side saw this?
No, this is the client, okay. The client corporate internal standards. And I'm sort of wondering, is this a maze and there's a piece of cheese somewhere? Am I the actual subject of the internal standards? Let's see, what can we do to this human? But we'll see. I can share, I don't know what your sharing things are, but I can, obviously share the deck and you can put it anywhere. I'm thinking about making the bash script I have that actually sets up everything from the resource group to the scale set using the Azure command line or the Azure command. I'm thinking about putting that up on a public repo on GitHub. So I will share that when that occurs, but otherwise I'm open to questions, and everybody knows where I am in the COVID bunker.
And with a gigantic bookshelf behind you. So yeah. Okay, well, thanks, Garth. This has been really good. Very following your path is very tough. And very interesting on the DevOps and the Terraform way to get these things out there to where they're all private and, like you said, reduce the risk of the client's perspective from with their policy. So yeah, please send us the hopefully links, because obviously you probably do updates to this over time or something like that. So we can always post links with the YouTube. Eventually this will be up on YouTube. We'll be able to click links and let people follow that for however long you keep your links up. Somebody asked, what about other cloud services with Terraform? I assume you haven't investigated AWS or Google GCP with Terraform yet, since you were just tasked with Azure.
Yeah, so this is actually, I'm GCP ignorant because I just haven't had the opportunity to work in that environment. I believe they've actually based it on Terraform, but don't quote me on that. The thing I still consider myself a Terraform noob here is that the first thing going into it is like I need a plugin for Azure. So that means my syntax for Azure is going to be different than my syntax for AWS. And, you know, I'd like that smokeless ashtray thing where I have one file and it abstracts things. I need a virtual network. Well, it will create a VNet in Azure, and it will create a VPC in AWS, but I don't believe that's the case. So I'm creating syntax specific things for each individual environment. And that means that my Azure Terraform is just not going to play well in AWS. So that's where I have that question mark, but I haven't, you know, obviously we would have to have a different Terraform in Google Cloud, and I don't know enough about Google yet to be able to say, well, what do they have for storage? Do they have the same public issues with their version of a bucket in the cloud? And I just haven't gotten there yet.
So we'll see an update to your presentation someday, maybe, with all the some of the other clouds as you get the needs for it. So that's really cool stuff.
Maybe it should be for the Alibaba cloud too.
Not going there, but yes. All righty. Thank you. We have now passed the hour, actually, so we're actually past our time. I see a few people have dropped off, but thank you for this presentation, Garth.
Thanks, Garth.
It was a pleasure.
Bye.
Bye-bye.
And thank you all, everybody. See you next month. Have a good day.
Thank you.